Fine-tuning changes the model's weights. Every parameter gets nudged through gradient descent until the model has internalized new information. It's like teaching a chef a new recipe, they cook it from memory forever. RAG does the opposite. The model's weights stay completely frozen. Instead, at inference time, you inject relevant documents from a vector database into the prompt. It's like handing the chef a cookbook mid-service, they look up the recipe every time, but never memorize it. This is the fundamental trade-off. Parametric memory, knowledge stored in the weights, versus non-parametric memory, knowledge stored in an external database. The original RAG paper by Lewis and Teen came out in 2020. LoRa, the technique that made fine-tuning practical on consumer hardware, came a year later. Both changed everything. RAG dominates when the data changes. Product docs that update weekly. A knowledge base that grows daily. With RAG, you just reindex the new documents, minutes, done. With fine-tuning, you're looking at hours or days of GPU training every single time. RAG also wins on scale. Need to search across millions of pages? Vector databases handle terabytes. Fine-tuning can only store what fits in the model's limited weights, roughly 1 to 10% of a 7 billion parameter model's capacity. And here's the killer metric: RAG reduces hallucination by 50 to 80% on knowledge tasks. NVIDIA's own benchmarks showed that. The model reads exactly the right context, so it doesn't have to guess. For the home lab crowd, this is huge. You can run a 7 billion parameter model with a local embedding model in ChromaDB, all under 8 gigs of VRAM, no training required. Time to production, RAG in days. Fine-tuning in weeks. But RAG can't change how the model thinks. That's where fine-tuning is irreplaceable. Need your model to always speak in a sarcastic tone? Prompt engineering won't get you there reliably. Fine-tuning will. Need it to refuse certain outputs with specific wording? Fine-tuning bakes that behavior into the model. Need structured output, valid JSON, every single time? Fine-tuning teaches the model the grammar of your format in a way that RAG context injection can't match. The latency difference matters too. Fine-tuning is a single forward pass, about 50 milliseconds for a 7 billion model on an RTX 4090. RAG adds retrieval time, 10 to 50 milliseconds, on top of generation. That's not a deal breaker for chat, but for real-time applications, every millisecond counts. On domain-specific generation tasks, style adherence, format compliance, fine-tuned models outperform RAG by 15 to 30% in human evaluation. And the local angle, QLoRA lets you fine-tune a 7 billion model on a single 24 gig GPU for about $3 in electricity. Tools like Unsloth make it twice as fast, using half the memory. Here's where it gets interesting. Most production systems don't pick one. They use both. The architecture is clean. A fine-tuned model handles all the how, tone, style, output format, behavior guardrails. A RAG pipeline handles all the what, the actual knowledge the model needs to answer the question. An orchestrator sits in the middle, building the prompt from both sources. Why does this work so well? Separation of concerns. Your fine-tuning dataset can be small, just 500 to 1,000 examples of how you want the model to behave. You don't need to pack encyclopedic knowledge into training examples. That's RAG's job. You get graceful degradation too. If the vector database is down or the retrieval comes back empty, the fine-tuned model still responds in the right style using its base knowledge. It falls back gracefully instead of falling over. And the update cycles are independent. Update the knowledge base daily. Refine-tune quarterly. Each pipeline moves at its own pace. Let's look at 3 real examples. First, a customer support bot for a SaaS company. They fine-tuned a Llama 3 8 billion model on 2,000 support transcripts for tone and escalation rules. Then they added RAG on their product documentation. Result: first response resolution went from 45% with prompting alone to 72%. Customer satisfaction scored 4.3 out of 5, matching human agents. Training cost? $8 on a single A100 for 2 hours with LoRa. Second, an internal code assistant at a midsize engineering org. They fine-tuned CodeLlama 13 billion on their team's PR history and code review comments. RAG provided internal API docs and architecture records. Code review acceptance for generated code jumped from 22% to 68%. That's 4 hours per developer per week saved. Third, a medical Q&A prototype. This one's all about safety. Fine-tuning taught the model to always include disclaimers, refuse to give diagnoses, and cite sources. RAG provided PubMed articles and drug interaction data. Citation accuracy hit 94%. Unsafe recommendations dropped to 0.02% compared to 1.8% for the base model with just prompt guardrails. Let's talk money. Upfront costs: fine-tuning runs $1 to $50 with LoRa on a local GPU, up to thousands if you go full fine-tuning in the cloud. RAG costs $0 for training compute, just the hardware you already own. But RAG needs more infrastructure services. You need an embedding model, a vector database, an indexing pipeline. Fine-tuning needs more raw compute, GPU time, CUDA, training frameworks. The recurring costs tell the real story. Updating knowledge with RAG takes minutes on CPU. Fine-tuning takes hours or days on GPU. If you update your data more than 3 to 5 times over the product's life, RAG is cheaper. Over 2 years on a local setup, the total cost of ownership looks like this. Fine-tuning only, about $700. RAG only, about $400. Hybrid, about $950. The hybrid is most expensive upfront, but it also gives the best results. Let's walk through 3 imaginary projects and see how the decision tree plays out. Project 1, a FAQ bot for a fast-moving SaaS company. The product ships weekly. New features, new docs, new support tickets every day. Dynamic knowledge problem: RAG wins. No contest. Project 2, a sarcastic support bot. The company policy is static, hasn't changed in years. But the tone is critical. You need the model to respond with a specific personality and follow strict escalation protocols. Behavior problem: fine-tuning wins. One and done. Project 3, a medical research assistant. Needs to cite current journal articles and always refuse unqualified advice. Behavior and dynamic knowledge both matter. That's the hybrid sweet spot. Fine-tune the safety guardrails and professional tone. RAG the medical literature. The rule of thumb is simple. Dynamic knowledge? RAG. Behavior change? Fine-tuning. Both? Hybrid? Neither? Pick whichever is cheapest. Or as one practitioner put it, fine-tune the personality, RAG the knowledge. The FT versus RAG debate is fading. It's becoming one question: which hybrid pattern fits your use case? Trend 1, online LoRa swapping. Imagine swapping fine-tuning adapters at inference time, one adapter for legal writing, one for casual chat, one for code review, all on the same base model, no full retrain needed. That's already possible today. Trend 2, RAG that fine-tunes. Use RAG to build training datasets, then fine-tune on those examples so common questions don't need retrieval. The model gets faster over time while still falling back to RAG for rare cases. Trend 3, agentic RAG. The model learns when to retrieve, how to decompose a question into subqueries, and when to iterate, turning retrieval from a single lookup into a reasoning loop. The convergence is clear. Parametric memory and non-parametric memory are blurring together. Most predictions say by 2027, pure RAG or pure fine-tuning will look like beginner mistakes. If you're building something today, start with RAG. It's the fastest path to shipping. Add fine-tuning only when you hit behavior limits, tone, style, safety, structured output. For production systems, plan for hybrid from day one. The tools are all free and run locally: llama.cpp, ChromaDB, Unsloth, Ultima. The local LLM community is leading this shift because they feel the trade-offs most acutely. If you're building with local LLMs, drop a comment: are you team fine-tuning, team RAG, or team hybrid? Subscribe for more practical AI engineering content. And check out the companion demo where I walk through building a hybrid system step by step.